Bam! Mr. Tarrou. In this algebra lesson, we are going to move beyond solving just one-step equations that we did in our previous lesson. You'll find a link of that in the description of this video, to solving two-step equations. And then our next lesson is going to be solving multi-step equations and solving equations where we have variables on both sides. But right now we're solving two-step linear equations. We're going to have 4 examples, the last 2 of which I'm going to give you some alternative ways of looks to those solutions. You might maybe want to consider it 6 examples. And the last example is going to be a word problem. Now we're only doing one word problem, one application problem. If you have trouble setting up equations from word problems, I'll include links to other lessons I've done as well to help you hopefully understand how to set those up. We're going to do these 2 steps in solving these 2-step equations, which is add or subtract away from the variable, and then multiply or divide away from a variable. When you're trying to solve for a variable, you're trying to isolate that variable. You're trying to get it alone, and so that it's just like x equals, and then there's a bunch of stuff on the right, or maybe there's just a single number, and it doesn't have to be x on the left and number on the right, but that's sort of how most of us become comfortable with them. And we're talking, of course, about the addition and subtraction property of equality that we talked about in our previous lesson, and the multiplication and division property of equality. With our examples, we're going to solve the equation and check your answer, because the great thing about solving equations, we can, make sure our answer is correct before turning in our test or our paper. A solution, of course, is a number that you can plug into an equation, and, that number allows the 2 sides to be equal. And if the 2 sides are not equal, then that number that you come up with that you think is the solution really is not. Okay. And also some equations don't even have solutions, but all the ones that we're going to do in this lesson will. And we are going to go from easy to hard. Okay, so we have 4 minus 3x is equal to 25. What value of x is going to be the value such that when we plug it in, the left side is equal to 25 like the right? So you want to remember that in an equation, and this is actually an open sentence as well because there's a variable in it, the equal sign breaks up or separates the left side of the equation to the right or from the right. And you want to look at that equation and go, where is my variable? Okay, well my variable is on the left side of the equal sign. So that means that we're going to want to identify what's on the left with the variable x and move everything away from it. So with the x, we have a 3. Now that 3, negative 3, is touching the x. Well, that's multiplication. And you don't have to save that multiplication and division for the last thing, but it does simplify the process. So we're going to get rid of that negative 3 or move it away from the x last. Now we also have another term on the left-hand side, which is just a value of 4. Terms are separated by addition and subtraction. And that 4 is just off by itself. It's not touching in any way through just direct contact, which is multiplication, or fraction bar, which is division. It's just off by itself, and that's a positive 4. That's an addition of 4 that's with the x. So we're going to do the inverse math operation. The inverse of addition, an addition of 4, is subtraction of 4. And, we can do anything, pretty much anything we want to an equation as long as we do it once to the left and once to the right. So the opposite of an addition of 4 is a subtraction of 4, and 4 minus 4 is equal to 0. So that basically, in effect, is going to cancel each other, those 4s are going to cancel each other out, moving that 4, as I like to say, over to the right side of the equation, away from the x. And we have negative 3. X is equal to then 25 minus 4 is equal to 21. Now the remaining value that is with the x is negative 3. It is touching. That indicates multiplication. And the inverse math operation to multiplication is division. So we're going to divide both sides by negative 3. And we're going to get a value of x, or we're going to come up with x is equal to negative 7. And notice my work is coming straight down. I'm not flip-flopping the 2 sides of the equation, and there's not, there are only 2 steps to solving these equations, but I'm being very careful to keep everything lined up and coming straight down, and there's the equal sign coming straight down, that sort of division dotted red line now, and I'm working my way down, and we have x is equal to negative 7, and x is completely isolated. There's no exponent, there's no division of anything, there's no addition or subtraction or any kind of multiplication left with x, and unless you want to consider that coefficient of 1, but Multiplying by 1 is that's the identity for multiplication, so it doesn't really do anything. And that's it. That's our answer. If this is indeed the answer, please make sure that you go ahead and you take that extra step, especially if your teacher requires it, to check your answer. And even if your teacher doesn't require it, wouldn't you like to know if that's actually right? Wouldn't you like to know that if you plug it in, do the two sides equal each other? So our check is going to be 4, that's supposed to be a K, minus 3 times, notice I'm using a parentheses when I plug in or substitute in this -7, always a good idea to do that. And is that indeed equal to 25? Oh, by the way, I don't know if you would just write a -7 without some kind of multiplication symbol, but if you don't include parentheses at all, it looks like -3 minus 7. If you put a multiplication symbol in there, if you're used to writing x for multiplication, well, now we're doing algebra, right, with all these variables and unknowns, and is that an x or an unknown value of x, or is that an actual multiplication symbol? So kind of try and avoid using that x for multiplication. If anything, just put a dot for multiplication. But again, I think it's a very, very good idea to always use parentheses when you substitute. So we have 4, -3 times -7 is positive 21. And that is indeed 25 is equal to 25. So this is a solution. We've checked it when we plugged it in. We got the two sides equal. Now on to our next example. -6 equals 2 plus y over 5. Okay, so how are we going to solve this for y? It looks a little bit different. We have a fraction bar in it, and the variable is on the right-hand side. And I'm perfectly happy with the way that equation is written. If you find it helpful, you could remember that this y has a coefficient of 1, and then sort of pull the 1/5 out in front of the y, and get -6 is equal to 2 plus 1 over 5 y. Okay, so whatever you like. Those are both very equivalent. Well, of course they mean the same. They're equivalent equations, just, they just look a little bit different. Pick however you like the best and feel most comfortable with. So we have our equal sign breaking up the two sides of our equation, and our variable is on the right-hand side of the equation. Again, an equation with a variable in it. It's called an open sentence. And because our variable is on the right, I'm going to want to identify those values that are on the right-hand side of the equation and move them away from the variable. Now, the 1/5 is touching the y, so it's a multiplication of 1/5 or a division of 5. And you want to, again, just for convenience sake, usually you want to leave that multiplication and division until the last step as you try and isolate your variable. So I also see a +2 on the right-hand side of our equation with the variable y. Well, the inverse math operation, the inverse of adding 2 that's on the right-hand side with the y is subtracting by 2. So there's a +2. We're going to subtract 2 from the right. We're going to subtract 2 from the left. And 2 minus 2 is equal to 0. So now we're left with our positive 1/5 y, or y over 5. I'm going to go back to that. And over here we have -6 minus 2. When you're combining numbers with the same sign, you want to add those numbers and keep the sign. So -6 plus -2 that's another way of saying it. -6 plus -2 or -6 minus 2 is going to be -8. If you do struggle with combining, adding, and subtracting numbers and working with those signs, well, you can think of a number line. We have 0, we have 1, and negative numbers are to the left, and so starting with -6, that's 1, 2, 3, 4, 5, 6 units to the left of 0. Now we're combining that with a -2, -1, -2, 2 more spaces to the left, is going to land us at -8. So we have -8 is equal to y over 5. Now we have 4 basic arithmetic operations: addition, subtraction, multiplication, and division, and y over 5. That's not an addition, that's not a subtraction, That's not a multiplication. Actually, that's a multiplication, right? When it's out front touching, that's a division. And the opposite of dividing by 5 is multiplying by 5. So we're going to take this equation and multiply. I don't know why. There we go. Let's get that green. We're going to multiply both sides of the equation by 5. Now that 5 is in the denominator and the y is in the numerator. And now I'm just writing a 5 off to the side. When you start working with fractions, it's helpful to have everything written as a fraction so you see those numerators, the tops, and the denominators line up. So let me go ahead and put that 5 over 1. We have 5. Okay, depends on how comfortable you are with fractions. A lot of you might just cross the 5's out because the multiplication of 5 and the division of 5, those are inverse math operations, so they are going to cancel out. But if you want to show every single step, which I like to do for teaching purposes, 5 times 1 is 5y over 5 times 1, which is 5, equals positive 5 times negative 8. Well, then positive times a negative is negative, and 5 times 8 is equal to 40. And now, I had a fraction, I had a division of 5. I multiplied by 5. Just to show every step, I'm still writing a fraction, but 5 divided by 5, that's equal to 1. So 1y, or just y, you don't really have to write that, is equal to negative 40. Is that the correct answer? Well, I can glance at my notes and I say, hey, that's what I got when I set up my notes for this lesson. But I can also, of course, good habit, and as far as I'm concerned required, check your answer. When I plug in negative 40, let's see here, we have negative 6 is equal to 2 plus negative 40 over 5. And negative 40 divided by 5 is negative 8. And 2 minus 8 is negative 6. Now, if I had worked with that 1 over 5 notation like I showed you, when you have that fractional coefficient, if you want to say it all fancy, if you have a fraction in front of your variable and you're trying to isolate that variable, you're supposed to multiply both sides of the equation by the reciprocal. And the reciprocal of 1/5, when you flip it, you get 5 over 1. So, equivalent work there. Okay, now on our other side, we have our third example. We've got x, and I said, by the way, I was going to do 2 of these examples, sort of like give them 2 different looks. I misspoke a little bit. That's just how much work this took. I thought I did it twice. But we're going to work through this. It is a horrible idea, as far as I'm concerned, to work with a mixed fraction. It's nice to see 6 and 3/5. That's 6 and some change. That's some value that's between the whole number of 6 and a whole number of 7. So I like mixed fractions as a final answer, but to work with them is not very pleasant. So we're going to want to convert this mixed fraction into an improper fraction by taking our denominator and multiplying it by the whole number part of our mixed fraction, and then add in that numerator that actually it's really a remainder from the division of some number divided by 5. So we're going to get x over 3 is equal to 4 is equal to 5 times 6 is equal to 30 plus 3. So 33 divided by 5. See, when you do 33 divided by 5, you get, 6 times 5 is 30, and there is your remainder, which is the sort of numerator of our fractional part of our mixed fraction, or mixed value. Now at this point, I don't know what your teachers are teaching you, or how they're teaching you to solve these problems. I'm just showing you in my format. I'm trying to show you this, these problems in this, well, I've erased the title, this 2-step process. So I want to show you how to solve this in 2 steps. I mean, that's the title of our section. But when you have one fraction equal to one fraction, you can also solve this equation through a process called cross multiplication, which only works when you have one fraction equal to one fraction. And to do that, it would be the denominator of this second fraction times the numerator, 5 times x minus 3 is equal to 4 times 33. Let's see here. 4 times 3 is 12, so 4 times 30 is 120. And 4 times 3 is again 12, so that's going to be 132. And now I kind of like have a brand new equation to solve for you that does not have any fractions in it. And I can continue this on. We would distribute through the parentheses and do some more stuff to finish solving this equation. I think maybe even some of you, I hope some of you actually can do that, but that's sort of leading into what we're going to be dealing with in our next video, which is solving multi-step equations. So nothing wrong with this. And, you know, solving this sort of equal proportion problem with cross multiplication is a process that pretty much every teacher covers. But thinking of that, you know, we're going to add or subtract away from the variable. We're going to multiply or divide away from the variable. I see a subtraction of 3, okay? So you might be thinking, well, if I'm just trying to isolate the x and his directions say, you know, add or subtract away from the variable first, let's add 3 to both sides. That's not going to work because this minus 3 is inside this rather large fraction. And a fraction bar doesn't just mean division, it's also a grouping symbol. It's all of the numerator divided by the denominator. So we're going to actually have to sort of not follow the directions, the suggested steps that I gave you at the beginning of this lesson. Those are just suggested steps. They don't, you know, it's not always like you don't have to follow the order of those exactly how I wrote it. And because that x minus 3 is grouped together by the fraction symbol, we need to undo the division of 4 first. Well, the opposite of dividing by 4, the inverse, math operation to division is multiplication. So we're going to multiply both sides of this equation by 4. Okay, so that is 4 over 1 to make it line up with this fraction, and 4 over 1 over here as well. And unlike the previous problem, I'm going to go ahead and, let's see here. Well, just to make sure I don't confuse anybody, let's go ahead and write this out. 4 parentheses x minus 3. I'm hardly really going to do anything here on the left except just write it a little bit cleaner. And 4 times 33, we just did that. That was 132 over 5. Now see, this factor of 4 and this sole factor of 4 in the denominator, those are going to cancel out. 4 divided by 4 is equal to 1. So those are going to cancel out, and we get x minus 3. There's just a 1 out front, and multiplying by 1 doesn't really do anything. Again, that's the identity value for multiplication, so we don't need those parentheses anymore. Over here we have 132 over 5. I am not going to just grab a calculator and turn that into a decimal, because you really should get away from, if you have to use a calculator, that's a horrible practice, and it's going to make your math studies later on through your classes much more difficult. So we're going to add 3 to both sides, and 3 minus 3, the inverse of subtraction is addition. That's of course going to cancel out. Over here, you know, we're adding fractions now, right? So to add fractions, you need common denominators. So I have a denominator of 5 and I have a denominator of 1, and when you have a denominator of 1, you can turn 1 into anything by multiplying. So I'm going to multiply this orange fraction by 5 over 5. And why do I have to multiply both the numerator and denominator by 5? Because 5 divided by 5 is equal to 1. So I'm effectively just multiplying by 1. I'm going to change the look of the fraction, but not its value. So now we have 132 over 5 plus 15 over 5. And now that we have common denominators, we're going to go ahead and just add the numerators. And that is going to come out to be 132 plus 15. Well, 132 plus 10 is 142. Another 5 is 147 over 5. And so our final answer, I'm starting to run out of room here, right, is x is equal to 147 over 5. Now I've also run out of room I might be able to squeeze it up here, but I'm going to do this off camera to make sure that this is actually the solution. When you plug in 147 over 5 into this, this other fraction, is it going to equal 6 3/5? You have to really know a lot about fractions to be able to check this answer. So let me step off. I'm going to erase the left-hand side of the board and show the check for this problem. So we got 147 over 5 minus 3 over 4. Does that equal to 33 over 5? Lots of good fraction review. Love those fractions. You can't cook, you can't use measuring cups, you can't use rulers, you can't do ratios. Well, fractions are ratios. So everything can't just be a decimal. A lot of round off error, a lot of issues. I know it's easier because you have your calculator, but we're going to go ahead and put this 3 over 1. We're going to combine those fractions, and this time we have a denominator 5 again, a denominator of 1. We're going to multiply that by 5 in the numerator and denominator. That is going to be 147 over 5 minus 15 over 5 over 4. See what kind of, just going reverse way over here, right? So 147 minus 15, well 147 minus 10 is 137. Now minus 5, 132. That is all over 4. By the way, that's 4 over 1. And what the heck? I mean, a fraction over a fraction, just trying to see if this is equal to 33 over 5. What am I supposed to do with that? Well, actually, let's finish the fraction notation. What does a fraction bar mean? It means division. So now we have 132 over 5 divided by 4 over 1. We don't really divide fractions, right? We multiply by the reciprocal. So now that is going to become 132 over 5 times 1 over 4. And does 132 have a factor of 2 or a factor of 4? Well, this denominator is equal to 5. I'm trying to match that. So I hope 132 has a denominator, or excuse me, a factor of 4. And that's going to be, let's see here, 132 divided by 4. That's going to go in there 3 times. Comes out with 12. Oh, that's a remainder of 1. Bring the 2 down. Hey, yeah, that's going to be 3 again. And so 132 is 33 times 4. The factor of 4 in the numerator coming across the multiplication symbol. This would not work if it was addition or subtraction. Going to cancel with that factor of 4. And we end up with what we had on the right, which is 33 over 5. So that, even though I'm circling it, is actually checking the validity of what I believe my answer is, which is 147 over 5. So that's our third example. Let's get on to our last algebraic example before we do our word problem. Bam! And again with the fractions, because hey, we do struggle with them as students, right? We have 2/3 c minus 5 over 2 is equal to 7. This one is going to go a little bit quicker than the previous one. So on the left side of the equation, again, we have the variable of c, so everything's going to come to the right away from it. We're going to want to move away from that variable of c. On the left-hand side, we have a subtraction of 5 over 2 and a multiplication of 2/3. We're going to undo that subtraction of 5 over 2 by doing the inverse math operation, which is, of course, now we know, addition. So we're going to add 5 over 2. The negative 5 over 2 and positive 5 over 2 are going to cancel out. We have 2/3 c is equal to, we need to create some common denominators, so let's put that 7 over 1 again. Pretty nice denominators here. We're going to multiply the numerator and denominator by 2. Again, that 2 over 2 canceling each other out to be just 1. We're just making the fraction look different, not actually wanting to change its value. And that's going to be 14 over 2 and plus 5 over 2. And now that we have our common denominators, we're just going to add the numerators. And 14 minus plus 5 is equal to 19 over 2. And now we want to get a leading coefficient that is equal to 1. Well, when you multiply reciprocals, those numerators and denominators will cancel out. So we're going to multiply both sides of this equation by 3 over 2. And that is going to be, you could write 3 times 2 is 6, over 2 times 3 is 6, and let the 6 over 6 cancel out to be 1. Or again, recognize that you're multiplying these, and across a multiplication symbol, that factor of 3 and that factor of 3 in the numerator and denominator are going to cancel out. These factors of 2 in the numerator and denominator are going to cancel out, leaving you with 1c is equal to, well, you almost kind of thought that these 2's were going to cancel, but they are both in the denominator. So 2 times 2 in the denominator is 4, and 3 times 10 is 30, and 3 times 9 is 27. So 30 and 27 make 57. And that's going to be our final answer. Now this time I'm not going to plug that back in and check it. Instead, I'd like to show you an alternative way of working out this problem. Going back to 2/3 c minus 5 over 2 is equal to 7. And I really almost don't want to show you this because I have so many students that come into my high school math classes, even honors students, that are weak in fractions. And I'm telling you, it really cripples their abilities to do well in my class until they get caught up on their basic math skills. So one of those being not being able to deal with fractions. You can get rid of the fractions and rewrite this in a form that is going to be a little bit easier to solve. You still have to understand how fractions work, but you avoid all the practice of using them, and you're not going right to a calculator making them decimals. You can multiply the common denominator through the entire equation, and that multiplication, since it's an inverse math operation to division, will cancel out the fractions if you do it right. So our denominators are 3 and 2. The multiples of 3 are 3, 6, 9. I'm thinking of the next answer, 12, 15. Our multiples of 2 are 2, 4, 6, 8. And there we have a LCM, a lowest common multiple. If I multiply that to both sides of the equation, again, you can do almost anything you want to both sides of an equation as long as you do it once to each side. Again, on the left, I'm going to make that line up. The numerators and denominators line up, so I'm going to write that as 6 over 1. We have 6 over 1 times 2 over 3. Well, 6 times 2 is 12 over 3c. And then distributing to the second term, we have 6 times 5 is 30 over 2. And that's equal to 42. Well, I still have fractions, right? What was the point of this? But 12 divided by 3 is equal to 4. And then 30 divided by 2 is equal to 15. That's 42. And now again, I got an equation. It's got a left and right hand side. We're going to find on the left hand side with the variable and a subtraction of 15. The inverse of that is addition. And we get 4c is equal to 57. We're then going to divide by 4 and get the same answer that we had before, which is c is equal to 57 over 4, the same answer we got over there. So you don't have to do these problems twice, of course, just a couple of different looks to the same problem. Pick a method to solve that you prefer best. Practice your fractions. One last problem, it's a word problem. The cost for a gallon of orange juice is 75 cents more than 3 times the cost of a gallon of water. If the orange juice is $4.50, how much is the water? Okay, so the cost for a gallon of orange juice is 75 cents. Okay, so this phrase of more than, that is an addition, of course, and you need to remember also that when you have these two words of more than and less than together, really is only important for less than, but it's a good habit to be in. You need to change the order of that around. So the 75 cents is going to come after the addition of, well, something out front. 3 times the cost of a gallon of water. Okay, so we're comparing something about the cost of orange juice and the cost of water. Well, that's which of those variables do we know nothing about? We don't know, well, we don't know either one, but we know how we come up with the orange juice price. It's 75 cents added to 3 times the cost of the water. And we know nothing about the price of the water, if you will. So really the water is the completely unknown value. And then from that, we're calculating the cost of the orange juice. So the water is actually the independent variable. It's the one, it's the value that's completely unknown. The water is, yeah, I have no idea. It's X. And the orange juice, the OJ, if you will, is 75 cents more than 3 times the cost of whatever the water is. Well, I don't know what the water is. So the orange juice is going to be 3 times the cost of the water. Well, no, it's 75 cents more than 3 times the cost of the water. So that is our information about the water. That is our information about the orange juice. Since we know nothing about the water other than it's helping to determine the cost of the orange juice, you could write this as basically your juice, because I'm going to run out, I think I'm going to run out of room. So I'm just going to write juice for orange juice is dependent on, is based on the price of the water. And that is going to be, like we see over here, 3 times the cost of the water plus 0.75 for 75 cents. I'm trying to write it in function notation. We have, and also use full words so we have an understanding of what this equation is actually saying, other than the fact that it's just a, you know, I guess an X or a Y or something like that. So our juice is dependent on the cost of the water, 3 times that plus 75 cents. Again, that water being the independent variable, helping us to figure out the output value of the cost of that orange juice. Oh yeah, that's right. The cost of the orange juice. Well, if the cost of that orange juice is $4.50, how much was the water to begin with? So now we have, oh, the overall price of the juice, orange juice, $4.50 is equal to 3, let's put W for water, plus 0.75. Oh, actually, excuse me, I can't do that because I already said that water was set equal to the variable of X, and I walked out. Oh, no, I didn't. With my eraser. Nope. All right, so I already defined water as the value of X. Okay, so now my X, here's my equal sign. Breaking up the two sides of my equation. On the right-hand side of the equation, we have a multiplication of 3, an addition of 0.75, and we're going to undo that addition of 75 cents. That's going to be 450 minus 3/4, 75 cents, is going to be $3.75. That is equal to 3x. With that x, we still have a multiplication of 3. The inverse math operation to multiplication is division, so we're going to divide each side by 3. That is going to be x is equal to $1.25. And if you want to check your work, you make sure that 450 is indeed equal to 3 times 125 plus 0.75, and that will check out. I know the video is getting kind of long, so that is going to check out. That is the end of our last example. I'm Mr. True. Thank you for watching. Bam! Go do your homework.